Hi, my name is Tahir from Smart Modeling Solutions. Today I'm going to talk about forecasting using different methods. So why it's important? Forecasting is an integral component of business planning. We need to be able to estimate things like sales, company expenses, to give an organization an idea of its way forward. Typically, forecasting relies on using historical data and our own expert judgment. Business utilize forecasting across various sectors, from retail, manufacturing, finance, supply chain management. By predicting future trends, companies can optimize their stock levels, reduce waste, or enhance customer satisfaction. For instance, retailers use sales forecasts to ensure they have enough products to meet demand, while manufacturers rely on production forecasts to schedule their operations. So, obviously, we need a good system which allows businesses to select and apply the best forecasting method for each product. This flexibility ensures greater accuracy, as different products often have different distinct demand patterns. But on the other side, forecasting systems should not be overly complex and should be practical for everyday business use. In this video, I will demonstrate you a few methods which are simple forecasting, historical forecasting, moving average, exponential smoothing, and regression analysis. This is a good balance between simplicity and effectiveness, as they are not overly complex and suitable for common forecasting needs. So we will use Quantrix as a multidimensional modeling tool which is very flexible and capable of handling large data. So we will use some key metrics to help us to assess and improve the accuracy of our forecasting methods. And we can see from these methods whether these forecasts deviate from the actual results, whether the best fit or worst fit. And we will have automatic selection. So automatic selection of the best fit method for each product potentially can save a lot of time. We can see performance of each method for each product. We will have certain metrics, we'll talk about it later. At the same time, we will have the flexibility of overriding auto selection to ensure expert oversight. All right, let's see the main interface where we choose and apply forecasting method to each product. Here on the top, we see the products, and we see also methods we can choose and apply to each product. On the top right side, we see the help, which shows description of the selected method. For example, now we selected moving average, and the product relevance, which kind of product are suitable for application of this method. Here we have a graph, which enables many features of the data to be visualized, including patterns, unusual observations, changes over time, outliers, seasonality, trends, etc. Here we have this chart shows actual sales, forecasted sales, and simulation data. So what is simulation data? We apply a chosen method to historical data to simulate a forecast for that period. By comparing simulated forecasts with actual data, we calculate how well each method predicts sales. The system then recommends the forecast method with the smallest deviations from actual sales as the best fit. On the right side, we have all methods listed, along with their key performance metrics, showing how accurately each method predicted sales. So we have here mean absolute deviation, which is the average of the absolute differences between actual and forecasted data, and it should be close to zero. We also have also mean absolute percentage error, which is useful for comparing methods because percentage error is easier to understand. Additionally, we have percent of accuracy. Percent of accuracy indicates forecast bias. Over 100% means over forecasting, under 100% means under forecasting. We can check here boxes to apply any of these methods that we find suitable for this product. The system automatically selects the method with the lowest error as its recommendation. Automatic recommendation potentially can save our time, especially if we have a lot of products. However, we can override the system recommendation by considering other factors and using our own judgment. We can use judgmental forecasting, particularly when we expect some shifts, technological advancement, or regulatory change, or we are in volatile markets, or we launch a new product and obviously we don't have historical data. At the bottom of the interface, we see input parameters that help control how each forecasting method is calculated. These parameters include things like coefficients, like here A, B, C, or alpha, beta, gamma, for equations used in certain methods. In addition, we can specify a particular time period to use as a base for our forecast. For example, in the case of moving average method, we set the period to run from September to December 2023. This means that the forecast will only use actual sales data from these months to make predictions. By doing so, we use the most recent and relevant data and keep our flexibility. Similarly, we can specify a time range for running simulation forecasts to evaluate the performance of each method. Okay, let's start with the product 1. We see that system recommends moving average as the forecast method because this method has the lowest deviation and percentage error. The moving average forecasting method is a simple yet powerful tool used to predict future values by averaging fixed number of past data. By using this method, we smooth out short-term fluctuations and highlight long-term trends. But this is important to know that in this simple moving average method, the past observations are weighted equally. So it doesn't mean whether the past data is recent or for a long time ago. In this case, actually we are happy with the system recommendation and we leave the automatically selected method unchanged. Okay, let's move to the product 2. According to the system recommendation, the best method is linear approximation. However, if we choose this method, we'll see that it uses only 2 data points to create a straight line that projected in the future. But we have in October here a data point which we believe is, so a very big drop here, which we believe is a one-time event and shouldn't be considered for forecasting. Linear approximation in this case may not be ideal choice. Instead, weighted moving average method is more appropriate here because it allows us to manually assign weights to each prior period. So that means we can assign higher importance, higher weight to recent data, for example, for December, and assign 0 weight to October because it's outlier, because it's not representative for our forecasting. By doing so, we can adjust the forecast based on our own judgment and choose the weighted moving average method, which also provides a good fit. The flexibility in the system allows us to effectively manage and exclude outliers when necessary. Okay, let's move on to product 3. Here, the system recommends the least square regression method, and we choose to base our forecasts on the time period from July-December 2023. From the chart, we can see that the least square regression matches the historical data well. It's also relevant for this product, as we can see in product relevance area, because there is no distinct seasonality or trend in this data. Both the least square regression method as well as linearly weighted moving average methods are suitable in this case. If we can go and check linearly weighted moving average method, we can see it's also a good match. But the difference here is when we look at the linearly weighted moving average method, the system automatically assigns linearly decreasing weights to each prior period. So both of these methods relevant to this product, suitable. They have both of them. They have very good performance metrics, MAD and MAPE. Therefore, we can choose either of them. Okay, let's select forecasting method for product 4. Here, system recommends is the simple exponential smoothing method as the best choice. In this method description, we can see that it is similar to linearly weighted moving average, but in this case, instead of linearly decreasing weights, we have exponentially decreasing weights, and the smallest weights are associated with the oldest observations. So we put more weight on recent observations. Here we also have a formula which use smoothing parameter alpha here in the input area. Here we can also use optimization to find the best alpha parameter that improves performance of this forecasting method. Luckily, Quantrix has a feature called solver we can use to run optimization by finding alpha which minimize the value of mean absolute deviation parameter. So we can go to solver and run solver. As you can see, solver improved our mean absolute deviation by changing alpha. Okay, let's move on to product 5. The system recommends the linear approximation as the best choice for this product. From the chart, we see that there is a clear upward trend recently. We believe that data from August to December are representative for forecasting for the next year. So what this method does, it calculates straight line between two sales history data points and projects it in the future. Actually, we are satisfied with this selection of linear approximation method with a very good performance metrics, and we leave automatically selected method as it is. The linear approximation method is particularly useful for new product with very limited historical data. For example, for product 6, the system recommends also linear approximation with only 3 data points that we have, only very limited data, historical data. From October to December, we can employ this method to calculate this trend for a new product. Okay, let's see what forecasting method we can use for product 7. We see the best method suggested by the system is least square regression method. This is one of the popular methods. Here the system finds the line the best fit as close as possible to actual data. This method is suitable for products that have linear trend in the data, and here we see that from April to December, here, there's a trend there, and we project the straight line to the future. Here's the formula that is similar to the Linus function in Excel and work the same way. Also, we see that in the input area, calculated coefficients A and B for equations suggested by the system. This least square regression method has the best performance metrics, as we can see here, and we can keep this method automatically selected. All right, let's look at the product 8. Here the system suggests calculated percent over last year as the best choice, but we here expect some changes in demand due to our marketing activities, and we believe that we can have higher growth rate that we had in the past. That's why we would like to specify this growth rate as an input, even though the system suggests another method. So we can go to the input percent over last year method and add 15% in this input area. And this is expected growth rate, and override the system by selecting input percent over last year method. It's suitable here because this product has seasonality and trend, which obviously we see in the product relevance. And we just simply believe that this trend will be higher than historically observed. All right, let's move to the product 9. So here system suggests calculated percent over last year as a best fit. We observe seasonality with growth, and we assume that the recent growth will continue next year as well. So system suggestion has very good forecast performance metrics, And this calculated percent over last year method perfectly relevant to our product characteristics. Let's see the product 10. We see that system suggestion second order approximation. Based on that we have from May to December a slight curve here. And forecast calculated by using quadratic equation. System fits a parabolic curve to the data, not a straight line. And we have A, B, C coefficients of this formula here. We can also optimize by using solver. Now we see that this we have a very good match, and we leave that recommendation as it is. Product 11 has clear seasonality, as we can see here, and upward trend. Let's look at the automatically selected method. It's called Holt-Winters Exponential Smoothing. So this method is used to forecast future data points by considering three key components. So level, trend, and seasonality of the data. So Holt-Winters method has two types. One is multiplicative, another one is additive. So in Holt-Winters multiplicative exponential smoothing, seasonality changes proportionally with the level of series. For example, here we have seasonal impact, end of year sales getting bigger as overall sales increases. This is why multiplicative method would be more suitable here. We use solver again for to find alpha, beta, gamma, which lead to minimum mean absolute percentage error. In Holt-Winters additive exponential smoothing, which is suitable for product 12, seasonality effect remains roughly constant over time. For example, we see here in the product 12 seasonal impact. Summer sales, we see here from roughly June until the August. Summer sales stay relatively consistent over the years, every year. That's why additive method is more suitable. But in both cases, as we see for product 11, where we used multiplicative method, and also for product 12, where we use additive method, system correctly suggested the best method, best suitable method. This exponential smoothing, triple exponential smoothing is a little bit complex, but it's perfect. But we need to have it in our toolbox, because if we sell seasonal products with a trend, this is the best choice for forecasting. So in Quantrix, we have real-time calculation of total result across all products. Let me show you the graph. As soon as we choose the method or automatically selected method, the chart shows consolidated result for all products. If we change forecasting method, we can instantly see impact on total corporate sales on this chart. That means that in Quantrix, we can start with product forecasting and also continue with aggregating data, creating financial statement, etc. This is all in one package for people in forecasting, planning, controlling. All right, we have throughout this video, we explored various forecasting methods. Each of these has its unique advantage depending on the data characteristic and forecasting needs. We saw that linear approximation works well with the limited historical data, while Holt-Winters is great for data with clear seasonal trends. The calculated percent over last year is particularly effective for product experiencing steady growth. So for each product, with the help of the system, we could find the best forecasting method. But it's also important to test and validate our forecast against actual data and refine our approach continually. We will periodically review our forecasting and improve it with the time. I hope these can inspire you to try these forecasting methods with your own data. Feel free to contact me if you are interested in this model or you have any questions. Thank you very much for watching. Happy modeling with Quantrix.